Assalamu alaikum. So in the previous video I have made a circuit with op-amp where if I press the push button, this LED is on for a certain time and then it again gets turns off. And I will do the same thing with BJT. So I have many circuits here, so let's talk about the first circuit. Okay, so now in this circuit I have two push buttons here, but first let's press here. If I press the first push button, you can see this LED is on and then it again turns off. Let me do this thing again and you will see it is on for 5 to 6 seconds. But when you press this push button and you want to instantly turn this off, so press here, so this LED is turns off. Again press here, again press here, so you see this LED has been turned off. So how this circuit is working actually, so let's see the mechanism of this circuit. So this is actually that circuit I have pasted here. So let's see what happens here. Well, so you see one 5 volt battery is connecting in this point. That means this point's voltage is 5 volt, this point's voltage is 5 volt. And now when you press this push button, you create a short circuit for a very short time, and in this short time the current will flow in this direction to the capacitor, and this capacitor will be charged up to positive 5 volt. Now the question is, how much time this capacitor will need to be charged? The answer is instantly. The answer is instantly, because you see that here no resistor in this path, right? In this path there is no resistor, and that means the current will instantly charge this capacitor. Well, so if now you remove your finger from the push button, you will again make a short open circuit in this push button, but that's not the problem, because you have already made this capacitor to be fully charged, to be it's now this point's voltage is positive 5 volt. Now the question is what this capacitor will do now. This capacitor, you see this positive 5 volt appears in the base voltage of this transistor. That means this transistor will turns on and current will flow in this direction. That means you will find a voltage difference across this resistor, and that means this point's voltage will be BE. Actually this is the emitter voltage of this transistor, and this BE will appear here, this BE will appear here, and this voltage will turns on this transistor, so current will flow in this direction and this LED will turns on. So this high voltage in the capacitor helps the LED to turns on, but the question is, will this capacitor will always in the positive 5 volt? The answer is no, because now this capacitor will start discharging in this path through this resistor. That means after some time this capacitor's voltage will be 4 volt, then 3 volt, then 2, then 1, then 0.5, 0.4, 0.3, and you see now this base voltage of this transistor is only 0.3. That means this voltage is not enough to on this transistor, so this transistor will turns off, and this transistor will make this transistor to turns off, so no current will flow in this direction and no current will flow in through this LED, so this LED will turns off. So you can control this time, that how much time the capacitor will take to be discharged. So we know the time period tau is equal to RC. That means if you increase resistance or if you increase capacitance, then it will take a longer time to discharge. That means you will get a longer time when for which the LED will turns on. Well, so let's test this circuit. Okay, so now this is actually 33K. So now let's make it only 1K. So only 1K, that means it will take a very short time to discharge in this path, right? So let's see. So if I press here, you see this LED, the on time of the LED is so low now because you have decreased this resistance. Well, so now let's increase this resistance up to 100K, I mean 100K, and now let's see what happens if I press this push button. So now this LED is on for a very long time. Let's see, and now it's off. And if you can do the same thing by increasing this capacitance, now it's 1 microfarad, make it 10 microfarad. So you will see that this LED is on for a very long time, but you don't have too much time. You want to make this LED instantly off. So to do this, press here, and you see the LED has turned off. Let me do this thing again. Turns on, it will be on for a very long time, but you don't have too much time. Press here, and this LED has been turned off. So what this push button actually doing, let's see. Well, so let me delete all this stuff. Okay, so what I have told you, that if you press this push button, you will create a short circuit here. That means if you press this push button, the capacitor will be charged instantly and it will be positive 5 volt. Okay, so now if you press this push button, you will make a short circuit here. You will make a shorted path here, and you see this resistance is only 1K compared with this resistance. This resistance is too large. This is 47K, but this resistance is only 1K. That means after pressing this push button, you have created new discharging path through this resistor, and as this resistor is too low, we know that now the it will discharge fast, because now resistor is low. That means a lot of current will flow in this path. That means this capacitor will discharge too fast, and you will see that the LED is instantly turns off. Let me do this thing again. LED is on. If you press this push button, capacitor will have a new discharging path in this region. You see this is only 1K and this is 100K. That means this resistor is too low. Press here and the LED is off. Okay, so now I have another circuit here. So I have another circuit. If you press here, you can see that this LED is on for a long time. The difference between these two circuits are, here you have a resistor 100K to the ground, but here you don't have any 100K resistor to the ground. Instead you have a path. You can remove this 10 ohm. I just add this, no use of this 10K. Well, so if I push here, so now this capacitor is discharging through this path. So here you have one base emitter terminal, you have another base emitter terminal. So you have actually two base emitter terminal and also one LED to discharge this capacitor. That means it will take a lot of time, and I measured it takes 1 minute, around 1 minute for this LED to turns off. But if you want this LED to turn instantly, just press here and you see this LED is turned off. Well, so I hope you like these two circuits, and I haven't made this circuit practically yet on the breadboard, but I will make this circuit inshallah, and I will upload and share that circuit with you. And I have also made some other circuits in the breadboard, like stable multi vibrator, then touch sensor. You will love this, love the touch sensor. You will I also love that circuit using, I have made that using Darlington pair, so you can watch that circuit in my channel. So thank you.